In the last class, we discussed what is a hypothesis and what is concept learning. So, the concept learning is a search problem. So, in concept learning, we are searching for a best fit hypothesis. Now, let us take an example concept. The concept is whether a person is COVID positive This is the concept we want to learn, and we have seen that in the definition of hypothesis we need a limited data at least to propose an hypothesis. So let me take some sample data which is having 4 training examples. Let me paste it here, and if you observe this data, we have 4 examples, 1, 2, 3, 4, and these are called attributes. So our hypothesis will depend on these attributes cough, and which has the values of low, mild and high. Out of these 3, it may have any one value. Fever, which has 2 values, low and high. And smell, there are 2 values, yes and no. And taste, again 2 values, yes or no. And sore throat, yes or no. So based on these 5 attributes, we have a data whether a person is COVID positive or not. So this whether person is COVID positive or not is called C of X. So C of 1, the example 1 is yes, that means it is 1. C of example 2 is again yes, so it is 1. And third example is no, so it is C of 3 is no, 0, and C of 4 is again 1. Wherever it is 1 or S, we call them as positive training examples. Positive training examples. And wherever the data which is negative, we call that as negative training example. So here, how many positive training examples are there and how many negative training examples are there? If you see the data, out of 4 training examples, we have 3, 1, 2, 4 as yes. So this is positive training example, this is positive, this is negative training example, this is positive training example. Now based on these 4 data, 4 examples data, we want to propose a hypothesis, and the algorithm that we are going to learn today is called find S algorithm. Before that, let me introduce the most general hypothesis. That means given any symptoms, the person is affected with COVID, whether temperature is low or yes or mild, whether cough is low or mild or high, whether smell is yes or no, taste is yes or no, whatever may be the value, he will be positive, COVID positive. Any data, any value of data, irrespective of values of data, the given person will be positive. That means C of x, the target value is always 1. That type of hypothesis is represented. How many attributes are there? 5. So, question mark indicates any value is accepted. Any value is accepted. This is called most general hypothesis. Similarly, most specific hypothesis. That means whatever value, it will not be positive at all. Whatever may be the value, it is always not positive. That means C of x is always 0, not 1. That type of hypothesis is called most specific. That means we don't accept any value, null, null, null. Is it clear? Most general hypothesis. That means it can accept any value and your target value will be positive. So, if you take the value of cough, it may be mild, it may be high, it may be low, or it may be anything. Any value is accepted. Whereas in most specific, no value is accepted. So, in fineness of a algorithm, we start with most specific hypothesis. This is the most specific hypothesis. Then, based on this most specific hypothesis, we take each positive example and we will go on updating our hypothesis. Let us take the first example, first training example. What is our first training example here? H0. Now let us write H1. What is H1? H0 says no value is accepted. Now, by considering the first example, it is saying that it is a positive example, right? So, cough, if it is mild, is positive. So, in place of pi, I will write mild. Then, what it is saying? If the fever is high, then he is positive. So, I am replacing this pi with more general value. Pi means no value is accepted. Now, what I am saying is cough, the value mild is accepted. Fever, the value high is accepted. Then smell, yes. Smell loss, in other words, it is smell loss. Taste loss. So, smell loss, yes. So, S, and taste loss, S, and sore throat, S. So, this is my H1. So, what I have done? I have started with most specific hypothesis. Then I have updated my hypothesis based on the positive example. First positive example. Now, let us take the second positive example and try to update it. What is the second positive example? Here it is. So, let us consider the second example and write H2. What it says? High. So, H2, H1 says cough should be mild for a positive person. My example says, because this is positive, that means If a person has cough, mild cough or high cough, both may result in positive. That means both values are accepted, mild as well as high. So to accommodate both the values, I will write question mark. That means I can accept both the values. Now here, coming to the temperature. My previous hypothesis says if the temperature is high, the person is positive. But my training example, this data, second data says, even if the temperature or the fever is low, it may result in positive, COVID positive. So, to accommodate both the values, because both the values are right and valid, I will insert question mark. I will insert question mark. Now, the third, what is that? Taste or smell. Smell, I think. Smell. So, smell loss, yes. Here it is yes, here it is yes. So, I don't have any problem. I will just copy the same value. Taste loss, yes, yes. My hypothesis says yes. And example also confirms that. Then coming to the sore throat, my previous hypothesis says that if the sore throat is present, it may lead to positive. But the second example says, which is also a positive example, that means this person is also affected with COVID. So I say that even if there is no sore throat, also may be positive. That means yes or no, both the values are accepted. So what shall I do now? To accommodate both the values, I will write question mark. Now what about the third example? It is a negative example. Remember, find-S algorithm, that is one of the limitations of find-S algorithm. Find-S algorithm ignores negative training example. So we don't update any hypothesis based on negative training examples. Negative trainings. That means H3 is same as H2. No updation for negative. Now the fourth example. Fourth example. So H4, update our hypothesis. Now my hypothesis is question mark. That means it can accept any value, high or question mark. That means question mark is more general. It can accept any value. Here question mark and high. Question mark is more general. So I will take question mark because it will satisfy all the values. Then yes, and here it is yes. Then taste loss, yes, and here it is yes. Then sore throat, question mark, that means it can accept any value. So there are no more training examples to verify or to test. So what we say is, a person who have, whether his cough is low or mild, it is not, doesn't matter. Whether his fever is low or high, doesn't matter. But if the taste loss is present and smell loss is present, whether sore throat is present or not, he will be positive. He will be tested COVID positive. So this H4 is called maximally specific, not most specific, it is maximally specific hypothesis. So the find-S algorithm is an algorithm which outputs maximally specific hypothesis. It outputs that. Now let us take another example also, the textbook example, whether a person name with name Aldo, he will enjoy his favorite sport or not on a given day. on a given day. So there are 6 attributes: sky and with value sunny and rainy, air temperature warm or cold, humidity normal or high, wind strong only one value, water warm or cool, forecast same or change. So how many examples? 4 examples. How many positive? There are 3 S. So 3 positive examples and third one is negative examples. Now let us start again with find S algorithm. We will start our find S algorithm with most specific hypothesis. Most specific hypothesis. What is that most specific hypothesis? Which will not accept any values. That means he will not at all enjoy the favorite sport on whatever may be the conditions, whatever may be the day, whether the sky is sunny or rainy, air temperature is warm or cold, whether humidity is normal or high, whether wind is strong or not, water is warm or cool, forecast is same or change, he will not enjoy his sport. That is the most specific hypothesis. Now take the first example and let us try to update our hypothesis by this example data. So what is H1? The H1 is pi, no value is accepted, and here it is saying if the weather is sunny, he may go and enjoy the sport. So I will update my hypothesis which is not accepting any values with the values which are resulting in positive C of x is equal to 1. Here C of x is whether he will enjoy his favorite sport or not. So sunny, warm, normal. What is that normal? Humidity. Then wind strong. Then forecast water warm. Forecast same. This is my H1. How did I get it? I get that by considering the first training example, positive training example. Let me remind you, find S algorithm only considers positive training examples. It will not consider the negative training examples. So I started with most specific, and in find S algorithm we are going from most specific to general, and the final answer is called maximally specific hypothesis. Now what is H2? For H2 I need another example, positive example, the second example. So let me copy that here and let me update my hypothesis H2. Sunny, sunny, no change. So happy. That means both examples are not contradicting. Warm, warm, no contradiction. So I can put the same value in my hypothesis. But here the third attribute, which is humidity, first example says if the humidity is normal, he will enjoy the sport. The second example says that if the humidity is high, he will enjoy the sport. Both are true. So I want to accommodate both. So to accommodate the both values, I replace that with question mark. Then strong, strong, no change, no contradiction. Both are saying the same value. Then warm and warm, same and same. So I updated my hypothesis. Now what about H3? H3 is a negative example, so I will ignore it. H3 is same as H2. Why? Because it was negative example, negative training example. What about H4? To write H4, let us consider the fourth example, training example, which is positive. Remember, we will consider only positive examples in finders algorithm. So coming to H4, and if you see here, let me, sorry, so if you compare these two, H2 which is H3, so sunny, both are same, this is same as H3. So no contradiction, let me write sunny. Warm and warm, great warm. Question mark and high, I want general hypothesis. So question mark is more general than high, so I will keep general rather than a specific value. Strong. Did I miss any value in H2? Yes, I think warm I missed here, warm, and here it is also warm. So now it is warm and here it is cool. Both are true, both are positive. So what shall I do? To accommodate both the values, I will write question mark. Then same and change. Both are true. So to accommodate both the values, so this is maximally specific hypothesis for given training data using finders algorithm. So finders algorithm outputs a single hypothesis which is maximally specific. In the next session, we will discuss about the merits and demerits of this finders algorithm.